Hello everyone, I'm Vaishnavi Mahesha and today's topic for presentation is duality of similarity and clustering users and items. Moving on, we'll be discussing the approach of classification algorithms. An alternative approach for developing recommendation systems is using item profiles, utility matrices, and approaching it as an ML problem. To do so, we can consider the given data as our training set and build a classifier for each user to predict the item ratings. As we already know, decision tree is a collection of nodes. The interior nodes is a condition to classify the required object, and the leaf nodes or the external nodes acts as a rendering decision node. Um, so our process basically starts from the root node where the predicate is decided whether it is true or false. And if the predicate is true, we proceed with the left node of the node, or else we proceed with the right child node of the node. Repeat this experiment until we reach the leaf node, and then the leaf node classifies the object accordingly. So before constructing the decision, we need to decide upon the predicate of the internal nodes. There are several ways to select a predicate, but one must be very careful while doing so, as this may result in one child getting more positive cases and other getting all negative cases. Moving on, let us discuss the methods of measuring similarity. So Euclidean distance, Jaccard distance, and cosine distance are the three methods that I would like to discuss today. So coming to Euclidean distance, it is nothing but finding the distance between 2 points using Pythagoras theorem. In Jaccard distance, we ignore the values in the matrix and focus mainly on the set of rated items. In cosine distance, we replace the unknown values or the blank values with zero. But one disadvantage with this cosine distance is that if a value or rating is not present, this approach considers it as a negative review rather than a positive one. Moving on, we have duality of similarity. So, using utility matrix and measures of similarity, we can obtain similarity between user and items by recommending items to users based on their previous purchase or by observing the typical behavior of the users and items. So, few examples of where we use duality of similarity or the recommendation systems is YouTube, Netflix, and Amazon. So in these applications, they recommend us choices based upon our previous history. Next topic is clustering users and items. So let us consider a problem statement here. Given two items belonging to same genre, there might be very few users who bought or rated the both. Even if two users like the same genre, they may not have bought any items in common. So how do we approach this problem? We can solve this by selecting any of the distance measures of similarity as suggested, and we can perform clustering on users and items in the appropriate manner. Uh, Moving on, we have UV decomposition. So UV decomposition, let's consider the case of movies. Most of the users respond to a small number of features. They like certain genres, famous actors or actresses that they like. If we start with the utility matrix M with n rows and n columns, that may represent n users and n items, for example. Then there might be a matrix U with n rows and d columns and a matrix V with d rows and m columns, such that UV closely approximates to M in those entries with M uh, having no non-blank values. If so, then we have established that there are D dimensions that allow us to characterize both users and items closely. We can also use these entries in the product of UV to estimate the corresponding blank entry in the utility matrix M. So this process is mainly called as the UV decomposition. Moving on, final topic is root mean square error and incremental computation of UV decomposition. So while the root mean square error, we sum all the non-blank entries in M, and the square of the distances between the entry and the corresponding entry into the product UV is taken, and then mean of these squares is taken by dividing them with the number of terms in the sum, and a square root of mean is taken at the end. Minimizing the sum of the squares is the same as minimizing the square root of the average square. So we generally omit the last two steps in our running sample. Finding the UV decomposition with the least RMSE involves starting with some arbitrarily chosen u and v and repeatedly adjusting u and v to make the RSME smaller. So we pick among several measures to how close the product of uv is to m, um, and that is what is called as the typical choice. Thank you.